Hello, third, fourth, and sixth year student. This is Mohammed Abbas with acid-base disturbance. I have decided to put acid-base disturbance in the renal and respiratory system, but actually, it's a multi-system topic. Belongs to GI, endocrine, metabolism, right? So for simplicity, we want to put it on the renal and respiratory system. Let me apologize for starting this YouTube video late, but I assure you moving forward we'll have more regular pattern of YouTube videos. So I was in the Department of Chemical Pathology and Biochemistry, but for this YouTube video we'll do diverse topics. So I want to give credit and acknowledge Dr. Freddy Coker, who is currently a fellow, a candidate fellow at the West African College of Physicians, Department of Pediatric, studying to become a consultant pediatric cardiologist. This presentation was originally prepared by him, and I just made modifications on it. I also want to acknowledge Dr. Ifeolu John David, whose expertise in IT helped us to do this presentation in this fashion, such that we can show you the slides with the recordings on it. Right? So these are our objectives. At the end of this lecture, we want to make sure you understand how to recognize acid-base disturbance and how to interpret the results and see if you can manage acid-base disturbance. These are the laboratory values. These laboratory values I expect you to memorize. It's very easy to memorize. Please try to memorize the laboratory values for pH. pH has a very narrow range, 7.35 to 7.45. This number is very easy to remember. The numbers 35 and 45 are important in acid base. You see, partial pressure of carbon dioxide is 35 to 45, partial pressure of oxygen is 75 to 105, and base excess, which is not so clinically relevant, but you have to know, it's just basically the concentration of titrable base needed to titrate blood to pH 7.4 at 37 degrees, while partial pressure of carbon dioxide is held constant at 40 millimeter mercury. That's what base excess is. Usually ranges between -3 to +3. And then there is an anion gap. I'll tell you what anion gap is shortly. Please try to memorize these lab figures. Please try to memorize them. They are so easy to memorize. So because acid base, specifically pH, has a very narrow range, the body always tries to compensate. If pH falls, the body tries to compensate so that it brings the pH up. If pH goes up, the body tries to compensate to bring the pH down. That is what we mean by compensation, because pH changes, minor changes in pH can cause fatal problems in the body, right? It causes cardiac problems, it causes renal problems, it causes CNS problems, seizures, and all of this. So you don't want, the body does not want the pH to fluctuate. So because the pH should not fluctuate, that's why you have a number of mechanisms. There are three main mechanisms. There's a buffer system mainly regulated by bicarbonate and phosphate. The second mechanism of compensation is your respiratory system, which is usually acute, right? And then you have the kidneys, which are delayed. It takes several days to be employed. Carbon dioxide usually is the respiratory gas, and it is most helpful in acidosis. So these are the three mechanisms of compensation. The buffer system usually from day to day based on the foods we eat and all of that. The respiratory system based on what you do, it's usually acute, and then the renal system comes in at a later stage. The renal system is the most important, and the most important component of the renal or metabolic compensations. Please note, renal we can use interchangeably as metabolic compensation is bicarb. Remember bicarbonate. Bicarbonate is the main metabolite, that is involved in renal compensation of acid base. Phosphate and ammonia are also important, but remember bicarbonate. So the kidneys try to change reabsorption of bicarbonate when pH changes. Depending on the pH, the kidneys can either increase or decrease reabsorption of bicarbonate. So let's talk about the types of acid-base disturbance. There are basically two broad types of acid-base disturbance. You can have simple disturbance or a combined disturbance. A combined disturbance can either occur as a compensation or as mixed. I'll tell you shortly. So now let's look at the simple disturbances. There's something called metabolic acidosis, four of them. metabolic acidosis, metabolic alkalosis, respiratory acidosis, and respiratory alkalosis. So you may want to know the difference between acidosis and acidemia. Acidemia is basically increased hydrogen ion concentration in the blood, and acidosis is all those physical processes and chemical reactions that lead to increased hydrogen ion concentration in the blood. So it is acidosis that actually leads to acidemia. So, but the actual situation is acidemia. However, we can use them interchangeably, acidosis and acidemia, no problems at all. When we talk about metabolic acidosis, the first thing that should come to your mind is anion gap. Anion gap. Let me talk brief about anion gap. So, normally in the body, you have cations and anions. These are the main cations. You see them, sodium, potassium. The main anions, chloride, bicarbonate, these are their normal values. If you add all the cations, you get 147. If you add all the anions, you get 124. There is always a difference of 23, which is a laboratory gap. This, if you go to the laboratory, this is what you get. There's a gap. However, in reality, there is no gap. That means the difference between the cations and anions is accounted for by plasma proteins, hemoglobin, and other negatively charged proteins that are not measurable in the laboratory. So anion gap is technically a laboratory gap. In reality, in the body itself, there is no gap, right? But when you measure the cations and the anions in the lab, you find the gap. But there is an electroneutral state in the body, right? All body fluids are electroneutral. That means cations and anions are equal. So to explain that gap, plasma proteins, hemoglobin, and other things in the body which are not measurable account for this gap, right? So if you add all of these, you find a difference of 16. There's a difference of 16 if you take the main cations and the main anions, the main measurable ones. Sodium is the main cation, and chloride and bicarb are the main anions. So this is the formula for anion gap. You have to memorize it. Anion gap is equal to sodium concentration minus the sum of chloride and bicarb. So if it's greater than 16, then we say anion gap is elevated. So anion gap is used to differentiate between the causes of metabolic acidosis. There are some causes of metabolic acidosis that go along with raised anion gap. There are others that go along with normal anion gap. Those ones that go along with normal anion gap are called hyperchloremic metabolic acidosis. Why are they called hyperchloremic metabolic acidosis? Those ones that cause raised anion gap are otherwise called normochloremic metabolic acidosis. So, if you have a metabolic acidosis in which there is an increased loss of bicarb, bicarb is an alkalotic gas. Bicarbonate is an alkalotic gas. So if you lose bicarbonate, the pH of the blood goes down. When pH goes down, then that is acidosis. So bicarb and chloride are usually the main anions. So chloride will correspondingly increase because of a loss of bicarb. So to maintain the electroneutral state of body fluids, right? So when that happens, you have an increase in chloride, and then you have an increase in hydrogen chloride, which is acidic, right? However, you're also going to get an increase in bicarbonates to compensate for the increase in hydrogen chloride. So the situation is such that you have a loss of bicarb. There's going to be an increase in chloride. An increase in chloride is called hyperchloremic state. So if you have a metabolic acidosis with a loss of chloride, that type of metabolic acidosis is going to cause hyperchloremia. So it's a hyperchloremic metabolic acidosis, right? So now these are the causes of metabolic acidosis. You have to memorize this. Metabolic acidosis that cause raised anion gap and metabolic acidosis with normal anion gap. Please remember, metabolic acidosis with raised anion gap is the same thing as normochloremic metabolic acidosis. Metabolic acidosis with normal anion gap is hyperchloremic. So this is raised, this one is normal. Anion gap is raised, chloride is normal. Anion gap is normal, chloride is raised. Please remember the causes. I have given you a mnemonic, mood piles. This is a mnemonic, mood piles. It's easy to remember. Memorize this. The commonest cause of metabolic acidosis with raised anion gap is diabetic ketoacidosis, DKA. Diabetic ketoacidosis is so important. It's a metabolic complication of type 1 diabetes, right? And salicylate, late stage of salicylate causes metabolic acidosis with raised anion gap. And these are the other causes. The main causes of metabolic acidosis with normal anion gap are renal tubular acidosis and diarrhea. Renal tubular acidosis we'll talk about in another slide. There are 4 types of renal tubular acidosis. I'll talk about that in another video, sorry. So now, if you have a case of metabolic acidosis, you first want to find out the cause. You check anion gap, right? When you find out the anion gap, if the anion gap is raised, the causes belong to this category. If the anion gap is normal, it belongs to this. The main types are renal tubular acidosis and diarrhea. The main causes of normal anion gap metabolic acidosis, renal tubular acidosis and diarrhea, right? Renal tubular acidosis and diarrhea. So if you have between renal tubular acidosis and diarrhea, you can differentiate the two by using what we call urine anion gap. I'll tell you what urine anion gap is in another video. Let's look at metabolic alkalosis. So when we talk about metabolic alkalosis, the thing that comes to mind is cell line responsiveness. When we talk about metabolic alkalosis, the thing that comes to mind is cell line responsiveness. When we talk about metabolic acidosis, the thing that comes to mind is anion gap. Metabolic alkalosis, you think about cell line responsiveness, right? Cell line responsiveness. That is how you can treat, right? So depending on the cause of the metabolic alkalosis, you can treat with sodium, with normal saline, right? Some causes of metabolic alkalosis you cannot treat with normal saline. So if you have a urine concentration of chloride of less than 10 milliequivalent, then that is a saline responsive cause of metabolic alkalosis. I'll show you the causes just now. So you can treat with normal saline, and normal saline will correct the alkalosis. If you have high urinary chloride concentration and hypertension, then the cause of the metabolic alkalosis is usually saline resistant, so you cannot treat with normal saline in such a case. So these are the causes of metabolic alkalosis. You have to find out the saline responsiveness. Check urinary chloride level. If urinary chloride level is less than 10 milliequivalent per liter, then it is a saline responsive cause of metabolic alkalosis. The major cause is vomiting and loop diuretics. Vomiting and loop diuretics are the major causes of saline responsive type of metabolic alkalosis. For saline resistant, the major cause is primary hyperaldosteronism. Primary hyperaldosteronism. Hyperreninemic hypertension is also a cause, and this is congenital adrenal hyperplasia. 17 alpha hydroxylase deficiency and 11 beta hydroxylase deficiency are causes. I'll tell you in another video what congenital adrenal hyperplasia is. Renal artery stenosis is also a cause of metabolic alkalosis. So what is respiratory acidosis? The major causes of respiratory acidosis are airway obstruction, and drugs, opioids like heroin, tramadol is a weak opioid. These are common causes of respiratory acidosis. I'll tell you in another slide why we say it is a respiratory acidosis. So memorize these causes of respiratory acidosis. And then we talk about respiratory alkalosis. The major cause of respiratory alkalosis is hyperventilation. So when you hyperventilate, you get rid of carbon dioxide, which is an acidic gas, and it is in the respiratory system. Because you lose an acidic gas, then the pH becomes alkalotic. So that's a respiratory alkalosis. Hyperventilation is a major cause. These are the causes of hyperventilation, hysteria, and all of this. Salicylate, please take note. I have highlighted it here. Salicylate causes both metabolic acidosis in late stage and respiratory alkalosis in early stage. Please remember, respiratory alkalosis usually goes along with hypocalcemia. Why? Because calcium is usually found in 3 states. Calcium is free calcium, which is physiologically active. You have calcium that is bound to albumin, and then you have calcium that is complex to hydroxyapatite crystals. So calcium that is bound to albumin competes usually with hydrogen. So when you have alkalosis, that means the blood, the hydrogen ion concentration in the blood is low. So what happens? The body tries to regulate that. A hydrogen is released from albumin. It's released, it dissociates from albumin to come into the blood to become free hydrogen. In other words, to correct the alkalosis. When that happens, free calcium binds to albumin, reducing the amount of free calcium, causing hypocalcemia. So usually respiratory alkalosis causes symptoms of hypocalcemia. Symptoms of hypocalcemia include, you know what that means, tetany and all of that, seizures sometimes. Yeah. This is our most important slide. We're going to spend some time here. If you understand this algorithm, you will be able to identify every acid-base disturbance. Please, we'll spend some time here, right? We'll spend some time here so you understand the acid-base disturbance. When you're given an acid-base disturbance include the ABG, arterial blood gas. It includes pH, partial pressure of carbon dioxide, partial pressure of oxygen, bicarbonate, and base excess. Do not look at the others. Just pay attention to pH, partial pressure of carbon dioxide, and bicarb. Pay attention to pH, partial pressure of carbon dioxide, and the serum concentration of bicarb. This is bicarb, bicarbonate. HCO3 is bicarb. HCO3 is bicarbonate. I told you to memorize the normal values. I repeat, memorize the normal values. If you have a pH, right, that is less than 7.35, that's a low pH. Low pH means increased hydrogen ion concentration, and then that's acidosis. First thing when you're giving an ABG, look at the pH. If the pH is less than 7.35, then that's acidosis. If the pH is less than 7.35, then that's acidosis. So if you have a low pH, that is acidosis, right? So now you have a low pH, it is acidosis. What is your next step? Look at partial pressure of carbon dioxide. Please note, carbon dioxide is acidic. When you hear the word carbon dioxide, it's acidic. And carbon dioxide is in the lungs, it's part of the respiratory system, right? So look for carbon dioxide. If partial pressure of carbon dioxide is greater than normal partial pressure of carbon dioxide is between 35 and 45. If it's greater than 45, don't mind I've written here 40, but it's actually 45. If it's above 45, then it's a respiratory acidosis. If the partial pressure of carbon dioxide is above 45, it doesn't matter what bicarbonate is. If you check its acidosis and partial pressure of carbon dioxide is greater than normal, that is a respiratory acidosis. Carbon dioxide is an acidic gas, so when it accumulates in the blood, it causes acidosis, and that type of acidosis is respiratory acidosis, right? So now when you have a respiratory acidosis, the compensatory mechanism is going to be renal, that is metabolic. I'm going to use renal and metabolic interchangeably. I don't know what you've been taught, but usually they use it, the technical term is renal, but we can use it interchangeably. When you have a respiratory acidosis, the compensation is going to be renal compensation. How? The kidneys, because bicarbonate is a metabolic substrate. This is metabolic, right? Bicarbonate is a metabolite and it's alkalotic. It's an alkalotic metabolite. So the body tries to shift the pH towards normal. In an attempt to shift the pH towards normal, the body should increase alkalotic substances, and the main alkalotic substance in the blood is bicarb. So the body increases reabsorption. It increases reabsorption of bicarb. The body increases reabsorption of bicarb. So when it does that, the serum bicarb concentration is going to get above normal, right? It's going to be above normal. Normal serum bicarb is usually 18 to 22. So if you have serum bicarb above 24, I told you to memorize the normal values. Serum bicarb is going to be above normal because there is an increased reabsorption of bicarb, or in other words, the same thing as there is a decreased excretion. There is a decreased excretion of bicarb from the kidneys. That is a compensation. If you have a respiratory acidosis, if you have a low pH, that is acidosis, and you look the bicarb is either low or normal. Bicarb is either low or normal. Then, what am I saying? Carbon dioxide, sorry, you have an acidosis. You check carbon dioxide, partial pressure of carbon dioxide, PCO2, partial pressure of carbon dioxide is low or normal, then it is not a respiratory acidosis. So you look bicarb. If bicarb is less than normal, it's less than 22. If bicarb is less than normal, since bicarb is an alkalotic metabolite. Bicarb is an alkalotic metabolite. When you hear bicarbonate, it's alkalotic. When you hear carbon dioxide, it's acidotic. So because bicarb is low in the blood, right? So it is because of the low bicarbonate that you have in the acidosis. So that type of acidosis is metabolic. Bicarbonate always goes with metabolic. Carbon dioxide, partial pressure always goes with respiratory, right? So since partial pressure of carbon dioxide is low or normal, if partial pressure of carbon dioxide is low or normal in an acidic state, then the cause of the acidosis is not respiratory, it is metabolic. You check the bicarbonate concentration, it will be less than normal. When you have a metabolic acidosis, there's going to be a respiratory compensation. The body tries to shift the pH towards normal, and in shifting the pH towards normal, you have to bring an alkalotic gas. How do you increase the how do you bring an alkalotic gas? Respiratory compensation. Respiratory compensation, the body tries to get rid of an acidic substance. If you get rid of an acidic substance, then you increase alkalosis, right? You increase the alkaline gas. So what happens? You hyperventilate. When you hyperventilate, you breathe fast. When you breathe fast, you lose excess carbon dioxide, and that gives you low partial pressure of carbon dioxide. Let's go to a pH of above normal. If you check the pH and it is above normal, that is 7.45. That is an alkalotic state. When pH is above normal, that is an alkalotic state. If you have alkalosis, same thing, you're still going to look at partial pressure of carbon dioxide. Take the format, look at pH, then partial pressure of carbon dioxide. When you look at pH, then look at partial pressure of carbon dioxide, right? When partial pressure of carbon dioxide is less than normal, it's less than 35. If partial pressure of carbon dioxide is less than 35, what do? That means the cause of your acidosis, of your alkalosis, is respiratory, because carbon dioxide is an acidic gas. So if it is low, if carbon dioxide is low, then it is the low carbon dioxide that is shifting the pH towards alkalosis. So that's a respiratory alkalosis. You have a pH that is above 7.45, check partial pressure of carbon dioxide. If partial pressure of carbon dioxide is low, it's less than normal, then the alkalosis is respiratory. When you have a respiratory alkalosis, the kidneys are going to compensate, going to have renal compensation, which takes usually days, right? It takes days for the renal compensation to be employed, right? How does the kidneys compensate? Because bicarbonate is the major metabolite, is the major alkalotic metabolite. The kidneys will try to correct the alkalosis, so they want to get rid of excess bicarbonate. So the kidneys increase excretion. In other words, the kidneys decrease reabsorption of bicarb. This is what happens. Decrease reabsorption of bicarb. So serum bicarb levels will be less than normal. Good. When you have alkalosis, you check your partial pressure of carbon dioxide and it is either normal or high, then the cause of your alkalosis cannot be respiratory, because carbon dioxide is an acidic gas. It cannot cause excess carbon dioxide cannot cause alkalosis. So if you or normal carbon dioxide cannot cause alkalosis, at all. So if you have an alkalotic pH, and then the next thing you look, your pH is above no, your partial pressure of carbon dioxide is above 45, which is above normal, then the cause of your metabolic acidosis is likely metabolic. The cause of your alkalosis is likely metabolic. So you check your serum bicarb concentration. Serum bicarb will be likely above normal, more than 24. If that is the case, then your alkalosis is a metabolic alkalosis. Metabolic alkalosis. Bicarbonate is an alkalotic substrate, and it's usually metabolic, right? So if you have a metabolic alkalosis, the kidneys compensate acutely. The respiratory system compensates acutely. Respiratory compensation is usually acute. Renal compensation is usually delayed. So respiratory compensation, how do we get the respiratory compensation? The lungs are going to decrease ventilation. So you have hypoventilation. In metabolic alkalosis, you have hypoventilation. Why do you get hypoventilation? So you retain carbon dioxide. You try to retain carbon dioxide because carbon dioxide is an acidic gas. The body tries to retain it, so it neutralizes the alkalosis. However, metabolic alkalosis cannot be adequately compensated by respiratory compensation because it is limited. Respiratory compensation is limited by hypoxia. If you hypoventilate, that means you are not breathing in, you are not breathing out. If you do not breathe in, that means you are reducing your oxygen inhalation. If you reduce oxygen inhalation, that is going to cause hypoxia. Tissue hypoxia is not good. If you have hypoxia, you have deprivation of your oxidative phosphorylation, and then you have tissue damage and all of that, right? So let's go over this algorithm again. When you have a pH, when you have an ABG, please check the pH first. If pH is less than normal, then that's acidosis. If it's acidosis, you check carbon dioxide. If carbon dioxide is above normal, that's respiratory, and then the kidneys will compensate. If carbon dioxide is normal or low, you look by carb. If bicarb is low, then that's metabolic acidosis, and then the respiratory system will compensate. If your pH is above normal, that's alkalosis. You check your partial pressure of carbon dioxide. If partial pressure of carbon dioxide is less than normal, that's a respiratory alkalosis, and the kidneys will compensate. If you have a pH of above 7.5 alkalosis, you check your partial pressure of carbon dioxide. It is above normal or normal, then it cannot be, the cause of the alkalosis cannot be respiratory. You look your bicarbonate concentration. If it's above normal, then that's a metabolic alkalosis. The lungs are going to compensate. However, in metabolic alkalosis, respiratory compensation is limited by hypoxia. So we now want to look at another slide which talks about Rome. There's a professor called Rome. Professor Rome. Please remember Professor Rome. Professor Rome gave us a mnemonic, a very popular mnemonic. Professor Rome's mnemonic states that your respiratory acid base goes opposite to the pH. Your carbon dioxide goes opposite to your pH, right? And your metabolic goes in the same direction to your pH. This is all what Professor Rome says. If you look at your pH, first you look at your pH, and then you look at your partial pressure of carbon dioxide, like I told you. First look at pH and then look at partial pressure of carbon dioxide. If pH and partial pressure of carbon dioxide are going in the same direction, pH goes up, is alkalosis. Partial pressure of carbon dioxide goes down, that's definitely a respiratory alkalosis. For metabolic alkalosis or acidosis, they go in the same direction. If pH goes up, your partial pressure of carbon dioxide will go up in metabolic alkalosis. If pH goes down, that is acidosis, and your serum bicarbonate goes down, that is a metabolic acidosis. Yeah. So the combined disturbances, as I told you earlier, combined disturbances occur either as a result of a compensation, that is, you can have a metabolic acidosis and a compensatory respiratory alkalosis. So always compensation tries to go in the opposite direction of the primary disturbance. If you have a primary metabolic acidosis, the compensation will go in the opposite direction, that is the respiratory alkalosis. That is a combined disturbance. Or you can have a metabolic acidosis occurring together with a respiratory acidosis. That is what we mean by mixed disturbance. Mixed. You can have a mixed acidosis or a mixed alkalosis. When we say compensation, that means the primary disturbance and the compensation are going in opposite direction. If you have a primary respiratory alkalosis, the compensatory mechanism will be a metabolic acidosis, right? So now this is another organogram telling you the stepwise approach. First, look at pH, and then look at partial pressure of carbon dioxide, and then bicarb, right? So now let's see if someone has a metabolic acidosis. For example, what are you going to look at? Always metabolic acidosis, check anion gap. Formula for anion gap, you should remember. The formula for anion gap is sodium, concentration of sodium minus the sum of bicarbonate and chloride. So if anion gap is raised, that is above 16, you know the causes. If the anion gap is normal, you know the causes, right? So when you have a metabolic acidosis, what do you expect? You expect the body to compensate, and the compensation is usually a respiratory compensation. So you can predict, right? So if you have a metabolic acidosis, there are three outcomes. One, you can have a primary metabolic acidosis without any compensation. Two, you can have a metabolic acidosis with a respiratory alkalosis compensation. And three, you can have a metabolic acidosis as a primary disturbance and a concomitant respiratory acidosis. So those three are the possibilities. Metabolic acidosis, check anion gap. If anion gap is raised, you know the causes. If anion gap is normal, you know the causes, right? To predict whether there's going to be a metabolic acidosis with no compensation, or whether there is a metabolic acidosis and a compensation, or whether there is a metabolic acidosis and a mixed respiratory acidosis, we employ the Winter's formula. The Winter's formula will help us to tell. This is the formula. Partial pressure, you calculate the partial pressure of carbon dioxide. The predicted partial pressure of carbon dioxide, 1.5 times the bicarbonate concentration plus 8 plus or minus 2. Plus 8 plus or minus 2. This is a range. So now, when you have metabolic acidosis, you quickly calculate a predicted partial pressure of carbon dioxide. Say, for example, you have a metabolic acidosis. That means pH is low and your bicarbonate is likely low. If bicarbonate is low, let's say bicarbonate is 18. Take bicarbonate 18. So you quickly calculate your predicted partial pressure of carbon dioxide. If you say 1.5 times 18, right, plus 1.5 times 18 plus 8, that gives you 35. 35 plus 2, 37. 35 minus 2, that's 33. So you get a range of 33 to 37. If you have a bicarbonate concentration of 18, your predicted partial pressure of carbon dioxide will be in the range 33 to 37. Good. Now you look at your ABG. If the measured partial pressure of carbon dioxide is greater than the predicted, is greater than your range, that is 37, then that is a superimposed respiratory acidosis. So you have a mixed acidosis. You have a primary metabolic acidosis and a respiratory acidosis going on, right? If your measured by partial pressure of carbon dioxide is less than the predicted, like we said, our range is 33 to 37. If it's less than 33, that gives us an idea that there's a respiratory alkalosis, a compensatory respiratory alkalosis. So this is a very good slide that explains combined disturbance. You have a metabolic acidosis. It could be a primary metabolic acidosis only with no compensation or a partial compensation, or you can have a metabolic acidosis with respiratory alkalosis compensation, or you can have a metabolic acidosis and a mixed respiratory acidosis. A metabolic acidosis and a respiratory acidosis. So use the Winter's formula. Memorize the Winter's formula, please, because it's so important. Memorize the Winter's formula. Yeah, please memorize the Winter's formula. So this is a slide just explaining, summarizing the slide I used earlier, right? Metabolic acidosis, what happens, and all of the compensations that take place. This is it. And this is the appropriate compensation that takes place. This is the Winter's formula. If you have a metabolic acidosis, this is the compensation that takes place, the Winter's formula, right? And if you have a metabolic alkalosis, this is how the lungs are going to compensate. The lungs will hypoventilate. They will retain 0.7 millimeter mercury of partial pressure of carbon dioxide for every 1 millimole rise in bicarb. Because as we said, if you have metabolic alkalosis like here, that means you have a high serum bicarb. So to compensate, the lungs will retain carbon dioxide. The lungs will retain carbon dioxide by hypoventilating. However, this is limited by hypoxia. If you have acute respiratory acidosis, the kidneys are going to compensate in a few days. How do the kidneys compensate? Respiratory acidosis means you have increased partial pressure of carbon dioxide. So when your partial pressure of carbon dioxide go up, what happens? The kidneys will retain 1 millimole. The kidneys will retain 1 millimole. The kidneys will retain 1 millimole per liter of bicarb for every 10 millimeter mercury rise in partial pressure of carbon dioxide. If you have a respiratory alkalosis, the kidneys, what will they do? The kidneys will lose. Yeah, you have increased excretion of bicarb. 2 millimoles per liter of bicarbonate will be lost for every 10 millimeter mercury decrease in partial pressure of carbon dioxide. Because the respiratory alkalosis here, look, respiratory alkalosis means you have low partial pressure of carbon dioxide. So the kidneys will try to lose bicarb. So the kidneys will lose 2 millimole per liter for every 10 millimeter mercury rise in partial pressure of carbon dioxide. So let's see this. Please take note that metabolic derangement, this acid-base disturbance, is very important, especially patients that have cardiac problems, cardiac arrhythmia. It causes death. It can kill. Metabolic problems can kill patients. Please note that metabolic acidosis always go with hyperkalemia. Remember this, metabolic acidosis almost always, not always. There's one or two conditions in which you have metabolic acidosis going along with hypokalemia. I'll tell you in another video. And then you have metabolic alkalosis. Almost always go with hypokalemia. Carbon dioxide, as I have said, is an acidic gas and it is respiratory. By partial pressure of carbon dioxide goes up, that means you're having a respiratory problem. Good. In an acidic state. Bicarbonate is alkaline or basic and it is metabolic. So let's look at one case. This is a case of a 68-year-old man who has a long smoking history, and now today presents with shortness of breath and cough. These are the laboratory values, ABG. You have to remember the normal values. As soon as you see pH of 7.28, that tells you something is wrong. Partial pressure of oxygen, this is in kilopascal. Partial pressure of carbon dioxide, you see 6.7, you know something is wrong. Bicarbonate, you see 35, you know it's above the normal. So please memorize the normal values. So in other words, in order to help you to memorize, I've asked you to outline the abnormalities and then what is the most likely diagnosis. We have outlined the abnormalities, you can see them, and then the most likely diagnosis in this case is a patient who has an acute exacerbation of COPD. COPD, usually they have a stable pH. They have a stable acid base, almost stable because of the compensation. But if they have acute exacerbation, then the patient is likely going to have a low pH. That is why you have acidosis. That is why the patient has an acid. So the patient basically has a respiratory acidosis because your partial pressure of carbon dioxide is high. Partial pressure of carbon dioxide is high, and then the kidneys are compensating. The kidneys are trying to compensate in a few days. The patient is not fully compensated yet because the patient has partial compensation. Since he remains acidotic, his pH is still in the acidotic level. But as I told you, the kidneys usually compensate in a few days. They do not compensate acutely. This patient definitely will compensate in a few days, right? Because the kidneys are going to increase. They're going to increase the retention of bicarb. When they increase retention of bicarb will neutralize the increased carbon dioxide concentration. Remember, COPD usually they do not breathe properly, and because they do not breathe properly, carbon dioxide accumulates in their lungs, right? This is another case of a young man, a 20-year-old Okada driver who probably uh, abused tramadol. So tramadol, as I told you, is an opioid. It's a weak opioid. So what do they cause? What type of acid-base disturbance do they cause? Is it metabolic acidosis? You should be able to tell me by now. Is it metabolic alkalosis? Is the pH going to be normal? You're going to read this case. Read this case, right? The patient abused tramadol. Tramadol is an opioid. Opioid, what do they cause? What do opioids cause? Opioids, they suppress the respiratory center. And when they suppress the respiratory center, what happens? Carbon dioxide accumulates in the lung. When carbon dioxide accumulates in the lung, what is it? So this patient has D is the correct answer, respiratory acidosis. When carbon dioxide accumulates in the lung, what happens? It depresses the respiratory center, and that activates carbonic anhydrase, which is released from red blood cells and then causes distribution of carbonic acid to bicarbonate, right? And that produces hydrogen ions, resulting in respiratory acidosis. So we've tried to make this presentation as short as possible, and then we hope to see you in another video. If you have questions or comment, if you have questions, you can put them down on the comment section. Thank you.